All right, we're going to carry the information forward from a previous slide, when what we'll do is to find displacement, or how far we've moved from our starting point for the following intervals. And if we write the definition of velocity, velocity or average velocity during an interval is displacement divided by time. I'll rewrite displacement is the average velocity times the time interval. So if we know how fast we've moved on average and the elapsed time, it will allow us to find the displacement. So let's find the displacement for each of these intervals. And we'll start down here. We use the margins in order to perform the computation. In the first computation, we'll solve for the displacement in the first interval from 0 to 1 second. So if we go back and look, our average velocity in the first interval in the first second was 2 meters per second. So that displacement would be equal to the average velocity, which is positive 2 meters per second, times the time through which we would travel, the elapsed time, 1 second. So that displacement is 2 meters per second times 1 second. Cancel, cancel. Positive 2 meters. The next interval through which we travel is between 1 and 3 seconds. And that displacement would be equal to, again, the average velocity times the time. In the second segment, the average velocity is 4. So it's positive 4 meters per second, and that's a constant positive velocity. So the average and the instantaneous would be the same no matter when, and the interval through which we traveled was 2 seconds. 4 meters per second times 2 seconds will give a displacement of positive 8 meters. Now we traveled farther because we traveled faster on average, 4 as compared to 2, and a greater time interval. Let's come up and we'll place C here. C is the displacement from 3 to 4 seconds. So the displacement, again, is the average velocity times the time. So C will have an average velocity of positive 2 meters per second. Again, here's our starting speed, the ending speed, the middle value is positive 2, times the time through which we traveled, again 1 second, and that is positive 2 meters again. That's interesting. Here you're going with an increasing speed and you have a displacement of positive 2. Here a decreasing speed but a similar displacement. Same average speed, same time will give us displacements as compared to interval 1 or A. Letter D, solving for displacement from 4 to 5 seconds. It's interesting now the average velocity is negative. So if we solve for the displacement, it's the average velocity negative 2 meters per second times the elapsed time, again 1 second, in interval D, 4 to 5 seconds, negative 2 meters per second. And then lastly, the special case, let's put this in a different color because it's its own beast. We know that the displacement in that case is equal to the average velocity for the interval, 0 meters per second, times the elapsed time, let's do this. We're adding this interval. We'll go back, and so this is a special case. This would not be A, this will be F. And we'll go back and do a 0 meters per second. Let's do this interval. Let's say between 3 and 5 seconds, the average speed would be 0, and the elapsed time is 2. So we'd end up with no displacement between 3 and 5 seconds. That's because we're moving, but sometimes we're moving forward, and the first interval would be positive 2 meters per second. The second interval, 4 to 5 seconds, would be negative 2 meters per second, but on average our velocity is 0. So we end up with no displacement in that special case, so we're adding that. And then we'll go back and do letter E, and we did put letter F in there. Between 5 and 6 seconds, our displacement can be computed by taking the average velocity for that interval, which happens to be -4 meters per second, and we multiply it by the time through which we traveled, 1 second. So that gives us a displacement of -4 meters. Why so fast in that last interval? Even though the time is relatively small, the velocity that we have on average is relatively large. So again, big picture, we're using the definition of velocity and manipulating it in order to solve for displacement, and using not the initial and final values independently, but we come up with an average value. And the reason why we use an average value is that some of the time you're going slow, some of the time you're going fast, and we can account for that. Or the average velocity when you're going constant, some of the time you're going some speed, 4, and you end up the same speed. That middle value is equivalent to the initial and final values. Using the graph, again, is important in physics. We need to be able to determine what information is being presented in graphs. Not only do they tell us how fast they're going at points in time, we can use a graph in order to find the average values for velocity, and then from that determine displacement.